Very well. So now I expect you to ask, you gave us the method, the instruction, how to find the probability. What if we have a probability and we want to find the X value? First of all, let us talk about the Z-scores. If you have a normal distribution for a normal distribution, what we learned? We learned that, hey, we have a bell-shaped graph, and then in this bell-shaped graph, we have the mean, we have the standard deviation, mean plus 1 standard deviation, mean plus 2 standard deviation, and mean plus 3 standard deviation. And on the left-hand side, we have mean minus 1 standard deviation, mean minus 2 standard deviation, and mean minus 3 standard deviation. Well, I have X values on the horizontal line. These are all X values, X on the horizontal line. And this is the graph of normal probability distribution. The area below the graph is 100% or 1. In many cases, in many scenarios, you are not allowed to disclose the actual X values. As a statistician, in many cases, you are working with confidential X values. If the X values are confidential, we're interested in converting X values into Z values. Z is equal to X minus mean divided by standard deviation. It helps us to scale the values. Z values are scaled X values. So what's the graph like? Do we get the same graph? Yes. Z is also normally distributed. The graph is the same. However, on the horizontal line, you have Z instead of X. The same graph, the same normal distribution, but with Z values on the horizontal line. Now, take a look at this. If I take mean and plug that into the formula, what would be Z? Z becomes mean minus mean divided by standard deviation, which is 0 over standard deviation, or 0. So mean in the normal distribution is a number. It might be like we saw before, it might be like 24, it might be 130, but if we use this transformation formula, use this machine, it converts, it transforms into 0. So your mean was mu, now it becomes 0. You can convert each of these numbers into a Z-score. For example, take a look at this. I'm going to transform mu minus sigma into Z. So Z becomes mu minus sigma minus the mean divided by standard deviation. Mu minus mu, they cancel out each other. You're left with negative sigma over standard deviation, or negative 1. So this number on the left-hand side of mean is now negative 1. So this guy becomes negative 1. We can continue this process. On the right-hand side, we get a 1, 2, 3. On the left-hand side, negative 1, negative 2, negative 3. This is a machine, takes on values and transform them into some new values. Z values are fixed. Z values are numbers that are scaled, and it is 0, 1, 2, 3, negative 1, negative 2, negative 3. This graph is fixed. Z can be 0.5, 0.3, it can be 1.7, it can be 2.1, it can be 3.7, it can be a negative number, -1, -1.4, -2.2, and so on. These are all your z values. The area below the graph is also 100%. So what's the difference between these two? As you can see, you had your x. Now x values are all z values. We call this guy a normal distribution, and we call this guy with z a standard normal distribution. Normal distribution. Very well. So we introduced something new. Now we would like to know, how do we use our calculator to transform probabilities or areas to z or x? Take a look at this case. So let me erase these. We need more space. Mu minus sigma, mu, I think I need to rewrite this. Mu minus sigma. So let's take a look at this example. Example says, find the z-score that corresponds to a cumulative area of 0.3632. Okay, guys. First, let us understand what's going on. What is this number? How do I visualize this number? We have area. This is my area. Area is below the graph. And question says find z-score. It means that I'm dealing with standard normal distribution. So let us take a look at the graph together. The graph is here. I have my area, which is 0.3632 or 36.32%. That's the meaning of that. So where is 36.32? All of these is 100%. 100%, but you are taking roughly a third of the area. A third of the area, which is roughly here, 36% roughly. So this is my 36.32%. But what is the z-score? What is this number on the horizontal line? How do I find this? Note that when the area is given to you, you have to use inverse norm. So we look at our calculator and we need to find inverse norm. When probability is given, use inverse norm. This is the rule that we're going to follow. So where do I find inverse norm? Turn on your calculator. Second, Morse inverse norm. Okay, not that bad. You can manage that. Second, Morse, find inverse norm. Second, Morse inverse norm. Let us click. What's the area? Area is 0.3632. What is the mean? Since I'm dealing with the standard normal distribution, mean is 0, with standard deviation 1 unit. So it stays 0, it stays 1, and calculate. You have negative 0.35. This is my Z value, negative 0.35. I found my Z value associated to this area 36%. If you want to just take a look at this here, you have negative 0.35 is roughly here. So this is my, let's move it a little bit further here so it matches our area. Very good. We found the Z value. Example. Now find the Z-score that is associated corresponds to a cumulative area to the right side of 0.3632. Now I'm changing the area. I have a different area. How do I calculate the Z-score? So now your area is on the right-hand side. We have to graph it first. What's the graph like? This is my graph. This is my normal distribution. I have 0, I have negative 1, I have 1, 2, 3, negative 2, negative 3. The area to the right-hand side of 36.32%. Where is that area? That area is roughly here, to the right side. What is this Z-score? What is the Z value? First of all, you can say that since this portion and this portion are both the same portion, these two areas are the same. On the right-hand side, I get a positive 0.35. So you can say that since on the left-hand side, I have negative 0.35, on the right-hand side, I get a positive 0.35. So this is 0.35. Or you can use your calculator. Guys, remember that when you're using your calculator to find the Z-score, calculator only calculates to the left-hand side of the area. To find the right-hand side, we have to do a little bit of calculation. So this is 36.32%. What is the area on the left? You need to find this area first. The area to the left. It is, well, 100% or 1 minus 0.3632. This area is 0.6368 or 63.68%. This is 0.6368. Now you have to use the inverse norm for this area because calculator has the function that only calculates the Z-score for the left-hand side area. So now go to second, vars, and then inverse norm. For the inverse norm, you have to use the area on the left. So let us go to the calculator, second vars, go to inverse norm. The area to the left is 0.6368. The mean is 0. Standard deviation is 1 unit. So let us calculate. This calculation gives us 0.35. So Z is 0.35, roughly 0.35. That's how we calculate Z values. If it's on the left, you directly use your calculator. But if the area is on the right, we have to do a little bit of algebra ourselves. 100 minus the area, which is 36.32%, gives us the area 63.68%. We have to use the area on the left for our calculator, or you can just plug in this area in the calculator and get a negative number and then use common sense conclusion that it's going to be positive on the right hand side of 0. Question says, well, what is the Z value for the percentile? Find the Z score. The first one is the Z score that corresponds to percentile P sub 5. B, you have the percentile P sub 50, and you have the percentile P sub 90. Remember that when you're talking about percentile P sub 5 or the 5th percentile, 5th percentile, it means that we are dealing with the 5% of the area. The 5% of the area is very small. It's 5%. 5th percentile or 5%. When we are talking about 50th percentile, 50th percentile, we have the following: half of the area, 50% of the area. When we are talking about the 90th percentile, it means that you have 90% of the area. Percentile. You have 90% of the area. Where is the 90% of the area? Well, this is the 90% of your area. What is the Z-score in each case? Very good. So, what's the first one? You have 5% on the left-hand side. Remember that, guys, since we have a standard normal distribution, all of these are Z values. In the middle, we have the mean, which is 0. And then the standard deviation is always 1. So it says, hey, we have the area 5th percentile. You are looking at the very small area on the left-hand side. You have to use second vars and then inverse norm. Okay, second var, inverse norm. What is my area? 5th percentile. Convert this into decimal, 0.05. 0.05. Mean is 0, standard deviation is 1, and then boom, we have the Z-score, which is negative 1.64. Z is, this number is Z equals to negative 1.64. You have the area, now you found the Z. For example, you're looking for a job, and in the applications, you see they only select the first top 5% applicants for the job. So it means that you're looking at the 5% on the right-hand side. The Z-score for those applicants is 1.64. You can use that Z to find, for example, the exam score needed to be in the top 5th percentile. What about the 50th percentile? You don't need to look for the Z. Z is here. Z is 0. Z is 0. What about the 90%? The 90th percentile. Again, the same process. Second, vars, and we have inverse norm. Very well. Okay. Second vars, inverse norm. Now we have convert this guy into decimal point. 90, mean is 0, standard deviation is 1, and then we have the Z-score, which is 1.28. So this Z is 1.28. Z is 1.28. Very good. Very good. Now let us see one cool application here. So in this application, we have the following. Scores on a university entrance exam are normally distributed. The mean is given to us. Mean is 50. And the standard deviation is 10. So we have these two pieces of information here. Well, you know that the university only admits the top 10% of the applicants. What is the lowest score an applicant can earn and still be considered for the admission? So what do we have? It says you have a normal distribution, you have your important information, 50 as the mean, standard deviation as the 10. So how do we visualize this guy? Let's try to visualize the graph, the normal distribution. This is my normal distribution. This is the graph that I have. Well, the mean is 50. Very good. I know the mean is 50. What about the rest of the numbers? Mean plus 1 standard deviation, 60. 2 standard deviations, 70. 3 standard deviations, 80. Negative 10, 40, 30, and 20. Okay, this is the distribution of X values. Remember that. You do not have 0, so these are all X values. Where is the top 10%? Top 10%? It might be around, like, let's see, 10%, maybe around here, not that bad. Okay, so first you need to find the Z-score associated to 10%. Why is that? Remember, Z is a transformation. It's like a machine. You get X minus mean divided by standard deviation. It takes on your X values and just convert them into some Z values. So let us do some algebra. If we multiply Z and the standard deviation, it becomes X minus the mean. So my X becomes mean plus Z times standard deviation. I have my mean, I have my standard deviation. If I have Z, then I'm done. X is equal to 50 plus Z, whatever it is, times the standard deviation, which is 10. But I need to know what Z is. Luckily for me, I know how to use a calculator to find Z. The area on the right-hand side is 10%. So I can just find the area to the left, find the negative Z-score, and then use the positive one for the right-hand side. So let's see. Let's turn on the calculator. Second vars, inverse norm. The area is 10%, 0.10. Mean is 50. We're not going to use this mean. We're trying to find the Z-score. We need the Z associated to 10%. So mean is 0, standard deviation is 1. So the Z-score is negative 1.28. On the right-hand side, your Z is 1.28. So this is my Z. Z is 1.28. This is missing in my calculations. So we find Z and then we find X. X is equal to 50 plus, well, 12.8, or the score that I need is 62.8. This is the score that I need. The score that I need to be considered for the admission.